Well, hello, good morning, good noon, everyone. Welcome to our Brain Health and EU Lunchtime Forum. I am your host and your moderator. I'm Dr. Kate Zhong. I am the adjunct professor and director of innovation in the UNLV with Department of Brain Health. I am very excited today to present you two fantastic panelists to talk about traumatic brain injury and brain health. This is part of our lunchtime forum. In the last year or so, we have had many discussions in forum, and I'm going to show you just briefly. And you can get the slideshow going here. There we go. Okay. So in the last 8 months or so, we had different topics, covers a fairly broad range about brain health. We talked about brain health and diabetes, sleep and brain health, physical health and brain health, sleep, eating right, Alzheimer's brain health, women's brain health, risk, resilience and brain health. And today we'll be focusing on traumatic brain injury and brain health. So we had a wide range of speakers, and from neurologists, psychiatrists, neuropsychiatrists, a nutritionist, occupational therapist, and so from UNLV, from Cleveland Clinic, and of course, all of you who have logged in to participate. So thank you. This program has been growing. We are very excited to take it to the next level, and today will be the last one for year 2022. We look forward to seeing all of you in January 2023. We will be updating you with the speakers and the program information very shortly. So today, I'm very privileged to have two doctors here with me. Dr. Charles Bernick, who is a neurologist with the Cleveland Clinic, Ruvo Center for Brain Health. Dr. Bernick has nearly 30 years of experience in Alzheimer's research and patient care. He is the principal investigator for many clinical trials and clinical research. I know Dr. Bernick way back when I was the senior director of clinical research and the Ruvo Center. He is the director of one of the biggest professional athlete brain studies nationwide. We used to call that FIGHTER study. Charlie is instrumental in leading the effort for Nevada to set forth the mandatory requirement for the pre-fight brain testing for boxers and mixed martial art fighters. So this is Dr. Bernick with the John McCain and the Senate. I think, Johnny, you actually went to Washington, D.C. to testify in front of the Congress and talk about the vital importance of brain health. And of course, Dr. Bernick is really continuing leading the fight for brain health. So we are very privileged to have Dr. Bernick here to be one of our panelists. Our other panelist is Dr. Jefferson Kinney. Dr. Kinney is the neuroscientist, PhD. He is also the founding chair of the UNLV Department of Brain Health. He is also the founding director of PAM Cork Brain Health and a biomarker laboratory. He is the chair of the Chambers Grundy Center for Transformative Neuroscience in UNLV. Dr. Kinney brings a wealth of knowledge on detection, diagnosis, and the neurobiomarker research in the area of the traumatic brain injury. So today we'll be discussing about traumatic brain injuries. You know, we heard a lot about traumatic brain injury. So what is it? What does it mean? And what are some of the symptoms of traumatic brain injuries? And how do we diagnose traumatic brain injuries? How do we detect that? And what are some of the treatment for the brain injuries, specifically for the traumatic brain injuries? Dr. Bernick will share with us some of the studies, and he has been leading. And I think one of the questions we have always been wondering is that if the traumatic brain injury can lead to dementia or Alzheimer's. So this is something that Dr. Bernick and Dr. Kinney will share with us during the discussion. And then we will also share with you some very exciting update on the research with regard to the detections, the biomarkers, the FDA approved new detection and the treatment for the traumatic brain injury. And Dr. Kinney will also share with us something very exciting that is taking place at UNLV, focusing on the sports research and innovation, among which brain health is a very important pillar for the traumatic brain injury. And finally, we'll talk a little bit more about the prevention and how can we mitigate, how can we reduce the risk for the traumatic brain injury. So then we are open for questions and answers, but also feel free to type in questions while we continue our discussions. So welcome everyone. On that note, I'm going to get the discussion started. I'm going to turn to Dr. Bernick to start. So Dr. Bernick, according to the Center for Diseases Control, the CDC, every year in the United States alone, we have about 1 million people suffer from traumatic brain injuries. And out of that, almost a quarter of them require hospitalization. It's a huge, huge issue we are facing. And I wonder if you can share with us, what is traumatic brain injury?
Well, first, Kate, thanks for asking me to join you all. It's a pleasure to be here. So you'd think that would be a really easy question, like what's, it's a traumatic brain injury is an injury caused by trauma, but it's really kind of a little bit more complex because really we're talking about an injury to the brain that has to do with some impact. Now that impact could be some actually blow to the head that gets the head moving and accelerating. So the brain, which is, has a consistency of jello really, that sits in a very rigid box, which is your skull. So if you get that brain moving, it can bump against the wall of the skull. And so one is just a direct blow to the head, but it also could be that something that stops the movement of the brain, of the head. So for example, a fall, where you fall, so your head's accelerated, it's going down, and then it's immediately stopped. But that's not all. So you can have kind of movement or injury to the brain from pressure waves. This is what happens with blast injuries in the military, which is a real problem. So I think really what we're talking about is a group of possible ways to get the brain actually moving within the skull, and whether that's by a direct blow, by the head hitting something, or some other mechanical method of getting the brain moving. These all can result in the same type of injuries to the brain, which we call overall traumatic brain injury.
Thank you for that. I think that another one that we have heard a lot is the brain injury as a result of the car accident. That happen quite often as well. As a matter of fact, I think that's probably one of the leading causes for the traumatic brain injury in this country, along with fall. Isn't that right, Dr. Bernick?
Yeah, no, for sure. And again, like the car accidents is an example of the head moving and hitting something generally, the back of the seat, the windshield, whatever, the steering wheel. And I also want to comment, it's kind of interesting when you brought up the figure of 1 million people, who have this is clearly an underestimate, because most people who have a mild traumatic brain injury probably never seek any care and would never be counted in those numbers. It's the same like with COVID. If you don't report it, it's not counted. So I think really we're talking about not just 1 million, it's probably millions of head injuries, maybe on the milder spectrum, that happen on a yearly basis.
That's staggering, the number. So, we all have from time to time bump our heads and got into some kind of minor accident. So I would imagine there is a wide spectrum of the brain injury with regard to the overall severity, right? Some of which might be very mild, others can be very severe. Can you share with us a little bit how from the clinical perspective that's been defined?
Yeah, absolutely, Kate. Yeah, it is a spectrum. And so there's ways to classify it: mild, MTBI, mild traumatic brain injury, moderate, severe. For me, it kind of, I separate it into two kind of categories. So one is mild traumatic brain injury, where you don't see any gross changes in the brain. For example, if you do a brain scan, you don't see anything, but clearly the brain has been injured at a cellular level or a fiber level. You're stretching, injuring fibers, but you don't see that on a scan. And then you have more moderate to severe injuries, which does result in some physical injury to the brain that's visible. So you could have a little bleed in the brain, or outside the brain, or you could, tear tissue with a penetrating injury to the skull. So I think, in my mind, there's kind of these mild traumatic brain injuries, which I think the more common, expression now is concussion. I think we use concussion for a lot of these mild traumatic brain injuries. And then there's everything else that, and those are the ones that are more severe, that end up in hospitals, that, then do have sequelae, but it's kind of a different fish than these concussions and milder, which are of course much more common.
I think we heard the term concussion quite common, even among the kids playing in the football field, to the bull rider we were just talking about, or somebody fall from the ladder. What is concussion? And what is the difference between a concussion and TBI, if there is a difference?
Yeah, so I would put a mild TBI, so mild TBI kind of in the same category as concussion. And concussion is really defined by just being a transient, that is a passing impairment of neurological function. So that could be where you're just dazed, you have a blow to the head or an impact to the head and you're dazed, you're stunned, you could, to the point where you're knocked out. I mean, it's a spectrum. You could have, slurred speech. You could be, kind of off balance, like the many of us who saw the pictures of Tua, who plays, the quarterback for Miami, and he was kind of staggering around after his hit. So concussion, it really refers to this transient neurological deficit that occurs, and in the absence of any obvious physical change in the brain, again, by imaging or other techniques. But again, it's the most common, it really is the most common form of a traumatic brain injury.
Great. So, Dr. Kinney, I'm going to turn to you for just a second, just from the brain structure, from the biochemical perspective. What happened when somebody had a traumatic brain injury?
Yeah, that's a great question. And I think to sort of highlight the same things that Dr. Bernick was saying. So, we worked on this and we do it at different layers, but there's lots of different types of traumatic brain injury, which means in terms of what's damaged or what's happening, it does differ. So the blunt force is different than a torsion or a twist. If it's from a penetrating injury, then it matters the location. And this is truthfully one of the reasons why this is very difficult to study, is because if you've seen 10 TBIs, you've seen 10 TBIs, right? There's variability in how people present, there's variability in severity. What we know pretty well is that there is an insult or an injury, there is oftentimes a bit of an inflammatory response to it. And this is where a lot of the attention and focus has been to better diagnose it, both clinically by colleagues, but also in terms of blood tests. And there's great progress there, but it's still widely variable, which makes there's not a one size fits all.
That seems to be the name of the game, isn't it? In terms of the definition of the TBI, with regards to the clinical presentation, and even the mild form of TBI, the concussion, has a variety of overall presentation. And speaking of a presentation, I want to come back to Dr. Bernick, just Can you describe to us very common clinical symptoms or signs in which that the patient will be presenting to the clinic, either in acute phase, suffering from TBI, or potentially chronically, days, weeks, years later when they come to clinic, presenting as the TBI? What are some of the symptoms?
Yeah, and I'll focus really on the concussion because again, these more severe injuries probably end up in the ER and in the hospital, so they're pretty clear. But concussion, yeah, so the immediate effects again can range from just getting your bell rung, just being dazed, to having problems with your equilibrium, your balance, your headaches. Headaches probably one of the more common. Difficulty concentrating. So that's the immediate, and then and subsequently, within the following day or days, again, headaches, difficulty concentrating or focusing or being in a fog, fatigue, irritability, or apathy. I mean, so you get behavioral, you have some kind of cognitive changes, you have balance changes, headaches. Now, not everybody gets any of all or any of these. I mean, it's kind of, that's unique in that some people get some symptoms, some people get others. The good news really is that, most of these resolve within could resolve within hours, but or within days. And, most people have complete resolution of their symptoms within a couple of weeks. However, there is a group that have a prolonged symptoms after concussion. We call them post-concussion syndrome. I mean, because these symptoms that should resolve don't. And they're just ongoing, again, related either to behavior, cognition, sleep, balance, disequilibrium, and so on. Again, fortunately, that's not as common, but definitely can occur. And I think really points out, and I know you're going to get to this, is this idea of early recognition and treatment. So to intervene, so we don't let things kind of get out of hand if we can prevent that from happening.
So at which point should the patient or the individual seek treatment? In the case of motor vehicle accident or very traumatic event, obviously they will go to the hospital. But if somebody just falls, they say, okay, I'm okay. I don't think I need to go to the hospital. Yeah. And which point that will be the advice from a physician that the individual should really seek medical treatment?
Well, I think there are a couple of things. So one is a prolonged loss of consciousness. So if somebody's, I mean, sometimes you get briefly knocked, you're knocked out briefly, but you come to and then you're okay, and that probably doesn't need to be seen in the emergency room. But if a person's had a prolonged loss of consciousness, and I'm talking about 10 minutes, 20 minutes before they really recover, and so those people probably should be seen. If symptoms are escalating, so again, over time, things should be getting better. But if, headaches are progressively getting worse, if balance problems are progressively getting worse, if people are just, kind of just totally foggy, I mean, and that's getting worse, so those type of things should be red flags that need attention. Probably some imaging, brain imaging, or at least evaluation by a provider. On the other hand, the flip side is, yeah, if you fall and get dazed, but you're within 10 or 15 minutes you're feeling better, may have a little headache, but you're feeling better, I don't know, those people probably don't need to get to the hospital or to the ER.
Well, thank you for that advice, Dr. Bernick. So when the patients do come to the hospital, do come to the clinic, can you tell us a little bit how you diagnose someone who potentially has TBI or concussion?
Yeah, well, right now it's just a clinical diagnosis, and so it really depends on getting the history from the patient. Now, what's interesting, of course, is that as part of concussion, there's uniformly some impairment of memory for the event. So people are a little foggy about kind of how, before the event what happened, or a little bit after the event. So they're not totally, they don't remember everything that exactly happened. So that's one of the more common signs of a concussion. that there's some impairment during that period of ability to lay down the memory of it. So the rest of it is really just getting a really thorough history of the symptoms they're having, making sure on examination that there's no, funny things we find on examination. I know Dr. Kinney is going to talk later about some of the newer things people are looking for in terms of trying to actually zero in on the type of damage that happens in the brain. And in fact, there's a whole industry now that's kind of built on, concussion diagnosis with gadgets and stuff. But I think still it's a clinical diagnosis. I also want to say this, it's kind of interesting because it's like that saying that, if a tree falls in the forest, but nobody's around, does it make any noise? Same thing with concussion. If somebody doesn't report it, if the person doesn't report any of these signs, it doesn't occur. It doesn't mean the brain hasn't been injured. It's just that we're dependent on clinically on that report by the patient or the individual, which is why, again, probably in sports, a lot of concussions are hidden. People don't complain. They don't want to, they want to continue playing and stuff like that.
I think under those circumstances that the collateral information from either the caregivers and family or the teammate will be really important to share with the doctors. I want to come to Dr. Kinney just briefly with regard to the diagnosis. Obviously, as Dr. Bernick pointed out, the current gold standard for diagnosing the concussion or TBI is still based on the clinical symptoms and evaluation. But more from the biological perspective, what has been done or what have we achieved?
Yeah, it's a great question, and Dr. Bernick is right. There's a pretty sizable industry right now of trying to identify better markers of traumatic brain injury, of concussion. Some of it's driven by sports associated. So the example that he gave about the Miami quarterback, right? He presented right away like there was a concussion problem, but did not actually receive that diagnosis, which is an interesting discussion. Then a week later got hit again and went completely unconscious, right? It became more severe. So the most promising stuff so far, about 4 years ago, the FDA approved 2 markers. One's called a ubiquitin marker. The other one is something called glial fibrillary acidic protein, or GFAP. Both of these got what's called breakthrough approval to really be tested for whether or not they are effective blood tests of traumatic brain injury in participants. And
So Dr. Kinney, sorry, just I want to be clear with our audience. So the breakthrough you're talking about is blood test.
Correct. So it was a blood collection or a blood test that they received approval to test to see whether or not this was diagnostically accurate, which is actually a big step forward for the FDA to approve something along those lines. In the last few years, it really hasn't gotten to the point that it's been largely used or demonstrated that it can better predict or detect than what the clinical interview. So exactly what Dr. Bernick was highlighting, it's still a clinical diagnosis. Both of these targets have something to do with inflammatory signaling this is evoked in traumatic brain injury and in some other neurological disorders. But beyond those 2, there are a wealth of additional targets from blood samples that are showing a lot of promise, and they're involved in our research studies, projects Dr. Bernick is doing, projects I'm doing, project that we actually have worked on together. And these range from a target called neurofilament light, which is a marker of damage to neurons, to several other inflammatory markers. What I can say with a great deal of confidence is that there is progress, but there is not yet something from a blood test that is definitively demonstrating somebody has had TBI, let alone to distinguish mild to more severe TBI.
That sounds fascinating. It sounds like for people who have suffered from TBI, something happened to their brain, which actually resulted in some kind of a change of the inflammatory process, and then that can be shown and subsequently detected in their blood. Is that how that biomarker thing works?
Yeah, so that's the idea. So the biomarker is really just, and I think I mentioned this on one of the other ones, but I realized that it changes around. So really all a biomarker is a way to take a glimpse into a biological process, right? The brain is a closed system. Inside your skull is your brain, and it's protected in a whole lot of different ways. So it's difficult to get access to the biology in your brain. But there are a number of things. Most people go to your physician and they take your cholesterol to determine your overall health and cardiovascular health. So cholesterol is a biomarker for a number of different things. So these are things that you can detect in the blood that are indicative of something going on in the brain, and in this case, to traumatic brain injury. And I think it's probably worth mentioning something else that Dr. Bernick highlighted is that, there's different severity, and in most people it clears. And in some people, you actually see a persistence or a worsening of what's going on. And a lot of what's being done for these biomarkers are trying to identify the ones that not only detect it, but try and figure out who is resilient or resistant against traumatic brain injury. So if it happens, they recover fairly quickly, as opposed to those that may have a different path or may not necessarily rebound as quickly. And if you put those two things together, you start to get at something from blood that could be diagnostically useful, but also that could be used to determine if a treatment is actually doing what it should to offset whatever damage has happened.
That's very exciting as far as research is going. Thank you for that, Dr. Kinney. You mentioned the ongoing study Dr. Bernick and you have been doing. So I want to turn that to Dr. Bernick to share with us a little bit about this very well-known and study, a fighter study, which I think it started about 12 years ago. When I was still at the Cleveland Clinic, I remember when we get this project started, it's very novel back then, but it has huge impact and is still currently ongoing. Can you tell us a little bit about that, what that is, and how would that impact, or how has that been impacting on our understanding and the treatment for TBI?
Yes, Kate. So, well, we were very proud of it, and you're right. You were part of it to get it started back in 2011 when we began this
Yes.
journey with it. So just as background, I mean, the impetus for this study was we were getting more and more information from pathological studies and such about a condition called chronic traumatic encephalopathy, or CTE. And this is, we believe, a neurodegenerative disease in the same family of things like Alzheimer's or Parkinson's. That's a progressive disease that continually results in injury to the brain and leads to dementia. But nobody knew anything about it. And we felt that we had the opportunity here in Las Vegas. Again, Las Vegas isn't always known for, its science, but we had this opportunity because this is the fight capital of the world. Fighters are constantly getting hit in the head. So, I mean, they're kind of a human model of head injury or mild traumatic brain injury. And Las Vegas is somewhat unique, I think, at least my impression of it is that, this is really a community that kind of hangs together. And we got the buy-in of the Nevada Athletic Commission and promoters and, the UFC, which is the mixed martial arts group. They bought in and participated. So we had the feasibility to get professional fighters and study them over a long period of time, because that never has been done. And we felt that was the only way to learn about what really happens, what's the natural history, what are the courses that can occur if you've been exposed to, in this case, repetitive head impacts. So anyway, so we started the study in 2011. The study really consists of annual evaluations. So people come in on once a year, and we just do a bunch of tests. They get an MRI scan. They get blood tests, some of which goes to Dr. Kinney. They get neuropsychological testing of their memory and stuff. They get behavioral measures. They get voice samples. They get, just anything we could think of. Currently, we have over 800 people in the study. Now, they're not all athletes. There's about 100 people who are what we call controls. That is, that these are people who've never been exposed to any head injuries. And so that becomes our comparison group. But over this period of 11 years, we've just accumulated a wealth of data and information. And I think we're really starting to uncover some of the important questions that occur. That is, can we recognize people who are starting to have progressive decline in their brain function? What are the risk factors aside from getting hit in the head? Are there genetic factors? Can we be able to intervene before? Just as you had mentioned, I guess one of the things we want to do at some point is prevention. So we're kind of working on all these questions with this study being the base of the data that we are collecting. So it's really been a very fun and exciting project, and one which really crosses internationally with colleagues. So of course we work with UNLV a lot, which of course we should, but we have collaborators at Johns Hopkins, in Sweden, at the University of Gothenburg. We have collaborators at the University of New Mexico, and so just kind of scattered around the country. I think it just as you said, it's gotten a lot of attention and is unique in what it does.
I think Dr. Bernick has been very modest, but this is really the leading study in the world. We never had such a big sample size and never had such a long study. And this is obviously such a special population. When we think about head injury, usually it's a result of an accident or injury. But in this population, the head injury is the intended outcome. You want to knock your opponent down. So this is a very special population to study the impact of the head injury and head trauma. And as Dr. Bernick pointed out, there's a lot of research have been done, a lot of papers have been published, and this really started from Las Vegas, and then we are going global. So I think congratulations, Dr. Bernick and Dr. Kinney, UNLV Cleveland Clinic. So this is really such a fantastic work, and then this is still continue. So I think that from there onward, the study has expanded to the football players and some other professional athletes as well. So this was the beginning of a very large initiative looking at how we can study the sports injury and its impact on the overall brain health. And one of which I think that I want to touch upon a little bit is the question that we ask ourselves in terms of the impact of the brain injury and dementia, right? So when you look at the boxers, the MMA fighters, many of them, when they get older, they develop dementia. And in fact, I think that some studies show that as high as about 99% of the retired football players suffer from CTE. So then what is the relationship between the TBI and dementia? And is that something that can be prevented? Or is TBI truly a risk factor for dementia? So I'm going to turn that to Dr. Bernick. Can you share with us from the clinical perspective? Then I'd love to have Dr. Kinney to share with us your thoughts and your research on this area.
Yeah, okay, so this is kind of a messy field. There's a fair amount of data or information, that's been published about head injury being a risk factor for dementia, for Alzheimer's disease, for Parkinson's disease, and so on. A lot of this is just based on kind of what we call epidemiological studies, looking at records from people in healthcare systems, for example, like at Kaiser or whatever. As it turns out, I think the latest information suggests that it's not so clear that it's a risk factor. We know from a big study looking at retired or former military, people that fought, in Korean wars, actually in some in World War II, that there was no relationship between a documented head injury and subsequent development of Alzheimer's disease. We've also found, this is very similar to what we find with the fighters and the football players, that there does not seem to be any increased risk of Alzheimer's disease. There is, of course, of CTE, as you brought out. So I don't think, my own kind of feeling about this is that head injury doesn't lead to, it doesn't cause, or put you at a higher risk of Alzheimer's disease. Or Parkinson's a little different. I do think, though, that if somebody has a predisposition to Alzheimer's disease and they get a head injury or repetitive head injuries, it will bring out the symptoms sooner. In other words, you lose your reserve, the reserve that you might have because of the head injury, and a disease that was going to be there anyway comes out sooner. You start to recognize it sooner. And so that's just my take of it, of the literature now. So having a head injury is probably not good. It's probably not good for you, but I don't think it necessarily actually is a cause itself of one of these degenerative diseases, except for CTE, which cannot be diagnosed, or has never been diagnosed, without a history of some repetitive head impacts, and usually at a high level.
So then the head injury can be a risk factor for dementia, and particularly for those people, as you say, Dr. Bernick, who are predisposed for Alzheimer's. I think there are some studies showing people who are, let's say, ApoE positive, if they had brain injury, that tend to accelerate the overall presentation, or the speed of the presentation of the dementia earlier than later.
Could be. Again, I really think this is kind of a mixed bag. Our findings with ApoE4, which is the risk factor for Alzheimer's disease that we all could potentially carry. So it doesn't seem to interact necessarily with the head injury. I think we just have to learn more about this. I think we just don't know enough. But hopefully, again, from studies like ours and others, that will be.
And Dr. Kinney is doing the research in this area as well. Dr. Kinney?
Yeah, no, so I think it's a great question, and Charlie is definitely being very modest. So the fighters study became the catalyst for lots of really, really interesting research questions, including, this was largely my entrance into a lot of the TBI work several years ago, was actually looking for markers in the blood in the fighters from the fighter study. And to this question, the original project that we were looking at was whether or not traumatic brain injury had a relevance to markers of Alzheimer's disease. So it was about, conferring risk towards the disease. And Charlie is absolutely right. This is a debate that goes back and forth. Part of the overlap here that people often talk about, and it comes out of our science and a lot of others, is that some of the same markers that we're looking at in blood in traumatic brain injury are also some of the same ones that are changed in Alzheimer's disease. But in truth, these are also changed in other neurodegenerative disease like Parkinson's. CTE is a little bit more, a lot of things happen faster in it. But like the projects that we started in our investigations now are a couple of markers on immune cells that we find in Alzheimer's patients. This is decreased by about 30%, and in the active and retired fighters, it was decreased somewhere around like 45%. So there is overlap here of showing that these changes mirror each other. But whether or not it's a changes in the brain associated with dementia, or whether or not it is something like leading into the specific Alzheimer's type of dementia, is very much an open question. I will say that there is this really nice confluence, or at least overlap, of many of these mechanisms. And with studies like the fighter studies and some Alzheimer's studies and a few others, we start to get to the point where the profile in the different populations look different. But even within the traumatic brain injury, the athletes who are repeatedly because all of us in our daily lives don't take blows to the head, right? Fighters, football players, maybe hockey players, maybe NASCAR drivers because their heads are vibrated around an awful lot, right? So what these studies have the ability to do is start to answer these questions, because the differences in those populations lets us start to tease out what is unique to the TBI, what is unique in Alzheimer's disease, and what things do they have in common. So as it sort of directs towards risk, there are a lot of risks for Alzheimer's disease. In one of the earlier calls or one of these sessions, we talked about diabetes, right? Our work on this is that diabetes evokes an immune response that has relevance to what you see in Alzheimer's disease. If that's the reason for the risk, then it's possible that traumatic brain injury could, but to what Dr. Bernick said, it probably matters an awful lot whether or not somebody is already somewhat on that trajectory. So we just don't know enough yet, but we know that there are some links.
I think it's very exciting that there have been a lot of research done in this area, and we are continuing this effort, from the NIH, NIA, and DOD, not only just studying the athletes, not just studying the dementia patient, but also, the soldiers and the high school children in the football field. I think that people are becoming much more aware of the concept of TBI. And also, I think another important issue people frequently want to address is how can we prevent TBI? So I would love to turn that to Dr. Bernick just to share with us a little bit. What would be your advice with regard to the mitigating the risk, reduce the risk for TBI? We understand for football players, for the boxers, it's not always possible for them to stop fighting or stop playing. But while they continue their career, what can they do to reduce the risk for TBI?
Yes, well, I think it's happening already. And I bet studies 20 or 30 years from now will find the incidence of CTE reduced because of just policy changes. The fact that at least in college and professional football, they're limiting the amount of practice time. I mean, contact time. We have concussion policies where people have to sit out, if they have had a concussion. There's this kind of initiative or turn more to flag football up to a certain age before kids start playing contact football. So I think all these things are good. As you might guess, I mean, the way to really prevent CTE or these long-term consequences is to reduce your exposure to head impacts. But I also would like to say that there needs to be this push for education, because it's really the recognition of concussion at all levels, and then appropriate treatment afterwards. As Dr. Kinney mentioned, I mean, that there's just this abundance of evidence that there's some neuroinflammation that's involved, once you have an injury, and there needs to be enough time for that inflammation to be handled by your system, by the brain, and so on. So just the Tua situation, the football player, you're much more susceptible to a second concussion if you had a first one. So I think a lot of it is recognition, appropriate to handling of that person afterwards, and making them sit out until they're really totally recovered. And hopefully with those type of things, we'll be able to really reduce these long-term consequences of head injury. But I think it's limiting the exposure, and then that recognition, if something does occur, that person be treated appropriately at that time.
Thank you, Dr. Bernick. We also talked about this early on with regard to some of the major causes for TBI, among which would be car accidents. So I think that wearing the seatbelt is so important. And then some accident like falling, particularly in the elderly population. So that be very careful in terms of the walking or using ladders, and also be mindful with your overall balance. This is something we also talked about, being physically active and exercise not only your strengths, your overall cardiovascular health, but also the balance is very important, obviously. I know that we actually have quite a bit of questions in the chat room. So at this point, I'm going to just turn that to the chat room and just bring a few questions, if I may, to both Dr. Kinney and Dr. Bernick. One of the audience asked about, can the brain sustain a penetrating injury and still survive?
Yes.
Yes.
The answer is yes. I mean, again, yeah. Well, there's this famous case of this guy who had a spike, through, this is in the 1800s, he had a railroad spike, that went right through his head. So you definitely could survive a penetrating injury. I mean, I guess it depends where it's penetrating. There's certain areas that are vital, and if you knock those out, you're out. But no, it can. Now you can get residual, so that's just it. So I think one of the questions had to do with the epilepsy. So you can have other residual from head injury, particularly penetrating head injuries such as epilepsy, or you could have just permanent changes in personality, memory, things like that. So it's not like it's doesn't have any consequences, but you definitely could survive.
Thank you for that. On the topic of epilepsy, one question from Julie is, how can someone who suffers from traumatic brain injury due to seizures participate on your clinical study? I think there are many clinical studies. So I think Dr. Bernick, maybe you can talk a little bit more about any current study.
I'm not aware of any specifically for that. I know we don't have anything here at the Cleveland Clinic that would really fit that. But I don't know what's around the country. I will say this, just in trials to begin with, as you know well, Kate, the government keeps a registry of all the studies and things that are going on, and so you can it's clinicaltrials.gov, and a person can go on to that, just type in what area you're interested in, and it will give you information about what's happening.
Thank you, Dr. Bernick. Another question is along the same line. How can somebody to enroll, to find the opportunity to enroll in your study? And what are some of the requirements for eligibility? So I think, again, Cleveland Clinic has information, that's a website that you can search for. And Dr. Bernick, I think that the clinic has all the clinical trials listed.
Yes, that's correct. And just even the website that you instituted, healthybrains.org, has links to the Cleveland Clinic clinical trials section. Again, most of the trials here, because we're so focused on Alzheimer's disease, Parkinson's disease, MS, and the traumatic brain injury one. So those are probably the ones you could find here.
Thank you. The other question is, can you have a brain injury that seems to be minor, and years later suffer from that brain injury? So I think that's an important question. That is really what is the long-term sequelae or consequences of brain injury, even if that might be minor at the time of the occurrence?
I'll I guess jump in first. I would say that that's not likely. I mean, so a minor head injury, we wouldn't expect any long-term consequences. Now, that's not to say you couldn't have lingering symptoms. For example, sometimes we do see people who develop migraines, or migrainous condition after a head injury, and the migrainous condition continues. But as far as leading to a neurodegenerative condition or dementia, you really would expect that. And I'll say this too, for those who have children or grandchildren, really the data looks like kids that play even up to high school football, the risk of long-term consequences are really not any greater than the general population. So, I mean, I think to get some of these long-term effects, you have to have significant exposure to, repetitive blows to the head. And I think there's probably a lot more benefit from, for example, playing sports, at least to a certain level, than not, even contact sports. So whether it's hockey or rugby or whatever, at least up to a high school level, or where you're not at the highest level of exposure, to me is probably okay. I'd rather them be a distance runner, or a swimmer, but I think, I think there's a lot of benefit from participating in these sports.
Well, you are a distance runner. We know that, Dr.
Oh,
Bernick.
yeah.
So, Dr. Kinney, we have touched upon a little bit in terms of the UNLV Sports Research Innovation Initiative, which I think is really fantastic. That really is a very exciting initiative. I wonder if you can share with us a little bit what that entails and how can people here get involved?
Yeah, no, thank you for actually bringing that up. So a few years ago, there's a collection of faculty here at UNLV that the common denominator is that they have some sort of association with sports. And as Vegas has been growing from the fighting capital to NFL and hockey and soccer and basketball, it's become somewhat of a sports mecca. So a group about 5 years ago started an effort to sort of solidify a focused effort on sports and sports related pieces. So that's sports management, it's sports entertainment and engagement and marketing, but there's also a component of this, which is a group that I'm part of or lead, is the brain health part of it. And our tie into that is our work on traumatic brain injury and both clinical and blood-based biomarkers, collaborations with Ruvo and with Ruvo Center and Dr. Bernick and others. And the effort is really around building a strong integrated approach to sports science, and sports health at UNLV. And with every passing year, the number of programs and the number of projects keeps on increasing. So to some of the questions here about enrollment or involvement, there will be in the next few years some studies out of UNLV, and these will be in collaboration with my co-panelist here, Dr. Bernick, right, of looking at TBI in lots of different populations, but also overall sports research. And it's just to grow this in a city that is well suited for it right now because of all the sport that has come here in the last few years.
Not surprisingly, this coincides with the Raiders and Golden Knight and Aces and soon baseball team. So it's very exciting for the city, and also I think that offers a great platform for us to conduct sports research and innovation. So as we are coming to almost the end of this forum, I want to remind our audiences in the chat section, we have provided many links, resources, website that we have talked about during this discussion. So feel free to take a look at that. And also that for the any further questions you may have, we're going to show you a email that you can send question to us. We'll be happy to address some of the questions we have not get a chance to address during this sessions. So I want to thank Dr. Bernick and Dr. Kinney for such an exciting discussion. Obviously this is such an important topic. That's the integrated part of what we have been talking about. That is how we can maintain our overall brain health. In addition to being very physically active, you eat well, reduce the stress, and being socially connected, keep your brain active, and also protecting your brain, right? So it's very important wearing a helmet, wearing seatbelt, and minimize the repeated exposure if all possible. So this is all what we have been striving for. Those are the pillars, what we call, that is important for your overall brain health. So on that note, I want to thank all of you for being here today. I also saw Dr. Ron Brown also is on the call. Dr. Brown is the Dean of our School of Integrated Health Sciences. So thank you for being here, Dr. Brown. And I want to thank you all and wish everyone a very happy and healthy holiday seasons. We will see you next year in January. I'm going to turn this back to Andy for some final Q&A. Andy?
Well, hello, everybody. Thank you for joining us today, and a big applause to the three doctors for sharing such wonderful knowledge with us. I'm going to share my screen here really quick that has a resource on it, a few resources actually. And there it is. If you are tech savvy and you'd like to take a very long, not very long, but longer satisfaction survey. You can scan that QR code. We'll also send it in a follow-up email for those of you who prefer to navigate that way. If you have any questions or comments, you can email us at brain.health@unlv.edu. And this video will be posted to our YouTube page in about a day or two, and we will send out that link as well. Again, if you guys have any questions or comments, we always welcome them. And at the conclusion of this Brain Health and You forum, technology says that a survey, a quick 4-question survey is going to pop up on your browser screen. If that happens, great. If that doesn't happen, don't worry. We'll follow up with a larger email in a couple of days. Thank you, everybody, and have a wonderful and blessed holiday and New Year's.
Thank you.